Hey everyone, let's take a look at an example of plotting a tangent graph. In this example, we'll plot y equals 3 tangent of 2x. Recall the general form of the variations of a tangent function looks like a tangent of bx minus c plus d. Here in our example, a is 3 and b is 2. Now, what does that mean? A is equal to 3, but it's not exactly amplitude. It will help us evaluate our 3 key points though, so we'll come back to that in a minute. B is equal to 2, and the period will be pi divided by b, so pi over 2. We use pi here and not 2 pi because tangent is pi periodic. We don't have a phase shift occurring in the input of our tangent function, and we also don't have a vertical shift. Since we don't have a phase shift, that means that the root or the midpoint will occur at x equals 0. So we already know that this function will have a point at 0, 0. So you can see that one period of the tangent function that we have here, 3 tangent of 2x, will occur when the values of 2x range from negative pi over 2 to pi over 2. And that just requires thinking back to the normal tangent function and what it looks like. It has asymptotes at negative pi over 2 and positive pi over 2. So as the values of 2x range between that, you will go through one period. If you divide this inequality through by that 2, you'll know that one period of 3 tangent of 2x is occurring between negative pi over 4 and pi over 4. And if you check, you can plug in the asymptotes or the values that will give you the asymptotes rather. So plugging in negative pi over 4, the input will become negative pi over 2, which is the asymptote for tangent. And likewise, plugging in pi over 4 will give you positive pi over 2 as the input, which is the other kind of right asymptote for tangent. So starting with the left asymptote, we're going to successively add by the period divided by 4. Recall that our period was pi over 2 in this example, and dividing that by 4 will give us pi over 8. And this is going to give us our kind of 3 key points. The left asymptote is occurring at negative pi over 4, so adding that pi over 8, this gives us the value of x when we're a quarter of the way into the period. That's negative pi over 8. Taking x1 and adding by pi over 8, again, we'll get 0, and that's the midpoint. This is the point that's occurring exactly in the middle of our period. Taking x2 and adding pi over 8 again will give us just pi over 8. That's the 3/4 point through the period. And then adding pi over 8 one more time to that gives us our right asymptote at pi over 4. And so you can take this information and start to fill in your table of values. And just remember, at negative pi over 4 and pi over 4, you have your 2 asymptotes. And then just like our technique when we plot our sines and cosines and those variations, these key points that we have should give us numbers that simplify to fairly simple inputs to evaluate tangent at. So we know that at the quarter interval, we are going to have the point negative 3. And this goes back to knowing that at negative pi over 4 for the normal tangent function, so just tangent of negative pi over 4, that's negative 1. So here's where that kind of amplitude or A comes back into play. This point here should be negative A at a quarter way through the period, and this is going to be positive A at 3/4 of the way through the period, which you can confirm just by plugging in these kind of key points from the previous page, which is what I've done here. The midpoint occurs at 0. Plugging in 0, like we said on one of the first slides here, gives us 0. Tangent of 2 times 0, that's tangent of 0, which is 0, 3 times 0. Take all of these 5 coordinate pairs that this table gives you and plot them like I've done here. And of course, at the left and right asymptotes, you're not plotting points, but you're just drawing dotted lines to play the roles of your asymptotes. And With these 3 points, you should be able to connect them smoothly, just remembering what the normal tangent of x function looks like. So that's what I've done here. And here we have a little bit more zoomed in. So at pi over 8, remember we're at the value 3, which is halfway between 2 and 4 here. And when we plugged in negative pi over 8 in our table, we found that was negative 3, or negative a. So at negative pi over 8, at the first quarter of the way into the interval, the function sits here at negative a, and at the 3/4 way point, the function is at positive a, or 3. And here we have asymptotic behavior. And now, remembering that the period was pi over 2, you can create this picture. You just draw another asymptote, pi over 2 after pi over 4. So pi over 4 plus pi over 2, in other words, which is 3 pi over 4. 5 pi over 4, which is just 3 pi over 4 plus pi over 2. So you can create many periods of this function by just plotting more of the asymptotes and just remembering that at 1/4 of the way into the interval, we're at negative 3, halfway we're at 0, and at 3/4 of the way into the interval, we're 3. And so you can repeat that pattern over and over to create the picture I have here. Thanks for watching, everybody.